The number on the atmospheric monitor read 47 minutes when Declan Morse ripped the maintenance hatch free and found nothing where the bypass coupling should have been. Not damaged, not corroded, not seized or cracked or leaking or any of the 14 failure modes cataloged in the Solari Maintenance Handbook for Atmospheric Bypass Couplings, Type IV, Standard Bore. Gone. The mounting socket was clean, the 4 anchor bolts seated in their channels with factory-fresh precision, the housing wiped smooth as though the component had been designed out of existence between one scheduled inspection and the next. Declan held his headlamp steady on the empty space and stared for 3 full seconds, which was about 2.5 seconds longer than a man with 47 minutes of breathable air should spend staring at anything. "Mora," he said into the hardline clipped to his collar, "the CDEC bypass coupling isn't failed, it's absent." The Solari chief technician's response came back immediately, layered with the harmonic buzz her species produced under acute cognitive stress. Humans felt it more than heard it, a subsonic vibration that lodged in the back of the jaw and sat there like a persistent low-grade ache. That is not possible. Diagnostics confirm the coupling is present and operating at standard capacity, pressure nominal across the bypass circuit. Flow index within acceptable parameters. The quarterly verification audit confirmed full operational status 11 days ago. I'm looking at the socket, Mora, with my eyes, my actual analog human eyes. There is nothing in it. No coupling, no seal, no mounting hardware, no residual material. Just a clean, round, empty hole where a component is supposed to live. A pause, not long in absolute terms, but time had changed shape since the primary loop went down, and every second now carried weight it hadn't carried 12 minutes ago. The atmospheric countdown on his wrist display ticked from 47 to 46. The station, Varathkal Processing Hub, a daylit industrial platform hanging in high orbit around the gas giant Tesserae's brightest moon, recycled atmosphere for 914 inhabitants across 12 operational decks. 11 minutes ago, without preamble and without warning, the primary atmospheric processing loop had stuttered, produced a sequence of pressure readings that contradicted its own stored baseline, and shut itself down with a diagnostic code that translated roughly as irreconcilable pressure reading, safety shutdown engaged. The secondary backup system should have engaged automatically through the CDEC bypass coupling, routing atmospheric flow around the failed primary loop, while the automated diagnostic engines worked through their fault trees and identified the problem. The secondary system had not engaged, because the CDEC bypass coupling, the physical connector between the primary and secondary atmospheric circuits, a hunk of machined alloy the size of a man's fist, was a ghost, present in every database on the station, monitored by every sensor in the environmental suite, verified and re-verified by quarterly automated audits that faithfully confirmed the operating status of a component that had no physical existence whatsoever. Declan backed out of the crawlway, shoulders scraping composite, boots finding purchase on service rungs that hadn't been climbed in years, and dropped into the sub-level corridor. He was 41 years old, wide across the chest and shoulders in the way men develop when they spend their careers reaching into tight mechanical spaces with heavy tools, and he moved with the controlled urgency of someone who understood 3 things about station-level atmospheric emergencies. Running burned oxygen you couldn't replace, panic burned it faster, and the fastest path through a crisis was a straight line from the problem to its solution with nothing wasted in between. The overhead panels flooded the corridor with full-spectrum daylight simulation. The Solari kept their stations perpetually bright, mimicking the twin-sun cycle of their homeworld, Solara Prime, where true darkness lasted only 40 minutes per planetary rotation. Every surface gleamed with a clinical, antiseptic clarity that had made Declan feel, for 14 solid months, like he was walking through a surgical theater that hadn't seen its first operation. He'd been Varathkal's sole human contractor for all of those 14 months. Atmospheric systems engineer, brought in because humans had developed a quiet, stubborn, largely unappreciated reputation among the Cellari for diagnosing the kinds of problems that automated monitoring systems couldn't see. Not because humans were smarter, the Cellari were, by most conventional metrics, significantly more intelligent, but because humans maintained a cultural habit that the Cellari had largely abandoned. They distrusted their own instruments. Not always, not categorically, but enough to occasionally put a hand on a pipe and feel whether the temperature matched what the screen said, or hold a gauge up to the light and read it with their own eyes instead of accepting the number the network provided. The Cellari were a logic primary species, tall, lean, silver-skinned, with six-fingered hands evolved for the precision interface work their civilization was built upon. They trusted their computational systems with a devotion that was, to a human engineer's eye, not quite professional confidence and not quite religious faith, but something that occupied the exact same emotional territory as both. Software was truth. Verified data was settled fact. The suggestion that a monitoring suite might be faithfully reporting the status of something that didn't physically exist wasn't merely a technical objection to a Cellari engineer. It was a category violation, an assault on the foundational assumption that measurement and reality were the same thing. Now the primary loop was dead. The backup was a fiction maintained by software measuring a phantom, and 914 people were breathing air that would run out in 44 minutes. Mora, I need the original installation records for the CDEC bypass coupling, not the current diagnostic file, not the quarterly audit history, not the maintenance log. The original commissioning data from when this station was built 41 years ago. The original commissioning data is archived in the Verathkal legacy baseline system. Retrieval requires unsealing a restricted archive tier, which involves a formal access request routed through the archive authority. The request alone will take approximately 17 minutes to process. Locating the specific documentation within the commissioning corpus may require additional time, as the files are stored in a legacy format that our current retrieval systems process at reduced. We do not have 17 minutes to fill out a form asking a filing cabinet for permission to look at a piece of paper. Where is the physical gauge cluster for this atmospheric section? Silence, not a processing pause, not the brief delay of a technician consulting a reference database. This was the silence of someone encountering a question from a direction they hadn't previously understood questions could come from, as though Declan had asked about the taste of a number or the weight of a Wednesday. The physical gauge cluster, Mora repeated, and the way she said it slowly, each syllable carrying the weight of genuine incomprehension, told him everything about the gap he was about to ask her to cross. Analog instrumentation, pressure gauges, flow meters, mechanical monitoring devices, the ones that were installed during original station construction before the automation upgrades. Bourdon tube gauges, probably brass-housed, connected directly to the atmospheric piping through sealed mechanical sensing elements. No power requirement, no software layer, no network connection, no self-verification protocol. Engineer Morse, this station was commissioned 41 years ago. The analog instrumentation suite was decommissioned during the second automation upgrade, approximately 26 years into the station's operational life. Those instruments are not part of the current monitoring architecture. They have not been maintained, calibrated, or inspected since their decommission date. They are not referenced in any current engineering standard, procedure, or audit protocol. Our systems. Were they removed, physically? Did someone go down to the sublevel with a wrench and actually pull them out of the walls? The question landed in the bright corridor like a dropped tool on a quiet deck. Declan was already moving toward the service lift, pulling the station's original construction schematics onto his tablet. The files were ancient, stored in a format the current operating system barely recognized. Archaeological curiosities from a technological era The Celari had moved beyond and preferred not to revisit. "I do not know," Mora said. Her harmonic buzz had shifted register, lower, steadier, the autonomic sound of a mind working at full capacity against a problem that fell outside its training parameters. The decommission protocol specifies that the analog instruments were taken offline and disconnected from the active monitoring network. Whether the physical hardware was subsequently extracted from the station infrastructure, or simply disconnected in place and left behind, that level of detail is not addressed in the decommission documentation. If nobody pulled them out of the walls, Mora, they are still in the walls. And right now those disconnected, decommissioned, uncertified instruments might be the only things on this station capable of telling us what is actually happening inside these pipes. He stepped into the service lift and hit the manual selector for sublevel 2, the mechanical infrastructure layer, the skeleton beneath the renovated skin. The lift descended through 2 deck transitions, the walls shifting from sleek modern paneling to bare construction composite, still wearing the textured impressions of its forming molds. The doors opened onto a corridor that was narrower, lower ceilinged, rawer, untouched by the cosmetic renovations that had remade the habitable decks above. The daylight strips down here were older units. Their spectral output shifted toward amber, casting a warm, late afternoon light that made the corridor feel like a place where time moved at a different pace than it did on the decks above. 42 minutes. The first gauge cluster was behind an access panel secured with a manual latch. A physical mechanism, metal tongue and metal slot, requiring no digital handshake, no authentication token, no network query. He pressed the release. The panel swung open on hinges that hadn't moved in more than 2 decades, protesting with a dry, reluctant groan that echoed off the bare composite walls. Behind it, mounted on a steel bracket bolted directly into the station's structural frame, sat a row of 7 analog pressure gauges. They were beautiful. That was the first thought, and he let himself have it for 1 second before the operational part of his mind reasserted itself. They were beautiful the way all obsolete precision instruments are beautiful, brass housings darkened with decades of slow atmospheric oxidation, to the color of old honey, glass faces hazed but uncracked, needle indicators resting at their stations on the graduated dials. Each needle held in place by nothing more sophisticated than the mechanical relationship between a curved Bourdon tube and the actual physical pressure of actual gas in an actual pipe. No power supply. No network connection. No software layer between the measurement and the reading. No self-verification protocol to confirm that the displayed number was consistent with the number the system expected to see. Just physics acting on metal, through a sealed mechanical linkage that had been sitting in this wall since before half the station's current inhabitants had been born. And on the face of the 7th gauge, the one whose Bourdon tube connected, through 6 meters of sealed copper capillary tubing, directly to the C-deck bypass loop, someone had scratched 7 small notches into the brass bezel. Declan leaned in, his headlamp narrowing to its tightest beam. The notches were hand-carved, deliberate, evenly spaced around the gauge face at specific pressure points on the graduated dial. Not factory markings, too individual, too rough at their edges, made with a pointed hand tool rather than a machine press. They were the kind of reference marks a working technician scratches into a gauge face when he needs to remember specific calibration points, and doesn't trust the printed scale to survive the decades between when the mark is made and when someone finally needs to read it. Each notch had a tiny number etched beside it, almost too small to read without the headlamp pressed close. 1 through 7. The 7th notch sat at 2.31. The number meant nothing in Celari standard atmospheric units. Their pressure scale operated on different baseline mathematics, different increments, a fundamentally different relationship between the abstract number and the physical quantity it described. But 2.31 was immediately, unmistakably recognizable to any human atmospheric engineer. It was a standard atmosphere pressure reading, in the unit system that human engineers had used since the earliest days of pressurized habitation. The same unit stamped into training equipment at every engineering academy on Earth and its colonies. Whoever had carved these 7 reference notches into this brass bezel 41 years ago had been thinking in human numbers and recording a human version of the truth. He checked the gauge needle. It rested at 0, not at the low end of the operating range, not at some degraded partial pressure indicating a slow leak or a compromised seal, at absolute 0. The gauge, disconnected from every digital system on the station, unmaintained for 26 years, ignored by every technician who had worked this sublevel since the automation upgrade, was reporting that the C-deck bypass loop contained no atmosphere whatsoever. The software upstairs said the same loop was pressurized at 2.34 standard Celari units and operating within nominal parameters. Mora, he kept his voice very controlled, diagnostic, a man reporting what the instrument said, not what his gut was screaming. The C-deck bypass loop reads 0 pressure on the analog gauge, not low pressure, 0. The loop is empty. It has been empty for what I suspect is a very long time. Your monitoring software is reading a pressure value that does not correspond to any physical reality inside the pipe it claims to be measuring. Engineer Morse, our diagnostic architecture does not fabricate readings. The harmonic buzz spiked hard enough that he felt it resonate in his back teeth. Each sensor measures directly from calibrated transducers that are verified against the established system baseline through automated quarterly cross-referencing protocols designed to catch exactly this type of. When was the baseline last physically verified? Not digitally, Mora, not through the automated self-check cycle. When did a person, someone with hands and eyes, physically go to a pipe, put an independent gauge on it, read the actual pressure, and compare that number to the number stored in the system? The silence that answered was not a pause. It was a void, the specific shape of empty space left behind when a load-bearing assumption is removed and nothing has yet been built to replace it. The baseline, Mora said, choosing each word with visible care, is established during original commissioning. It is maintained through automated self-verification protocols. Each quarterly cycle, the current sensor readings are compared against the stored baseline values. The baseline is then adjusted within acceptable drift tolerances to account for normal sensor aging and environmental variation. The process is designed to maintain calibration accuracy across the full operational life of. The system checks itself against itself. Yes. And if a sensor degraded, if the transducer reading drifted a fraction of a unit low over one cycle, and the self-verification protocol accepted that fraction as the new baseline, because the drift was within tolerance, because each individual step looked correct, and then verified the next reading against that slightly wrong number, and the next cycle's reading against that one, each quarter accepting a slightly larger fiction as the new settled truth. Cascading baseline drift, she said it very quietly. The harmonic buzz dropped to a frequency he had never heard from a Celari, something between vertigo and the instant before falling, when the body knows it has lost its footing, but the mind hasn't caught up yet. The accumulated error at each individual verification step would fall within the tolerance band. The total accumulated error across dozens of cycles would be invisible to the verification process, because the process is comparing each new reading against its own previous output. The drift would be detectable only through comparison to an external fixed reference that does not participate in the verification loop. One that. Someone knew this could happen. He tapped the 7th gauge. The brass rang with a small, clear, certain tone. Someone who worked here during original construction scratched 7 physical calibration references into these analog gauge bezels. 7 points along the operating pressure curve, numbered in human units. Fixed. permanent, unable to be updated, unable to self-verify, unable to drift. Because scratches carved into brass don't run firmware, and they don't adjust themselves to match what a monitoring system expects them to say. 38 minutes. He moved to the second gauge cluster, 20 meters aft behind another manual latch panel. Same protesting hinges, same row of brass gauges in their steel bracket, same hand-carved notches on the 7th dial, the same hand, the same sharp tool, the same deliberate spacing around the pressure curve. Needle position, 1.87. Software baseline for the corresponding loop pulled from his tablet, 2.19. Software high by 0.32 units. A third of a unit of phantom pressure that existed nowhere except inside the digital model. Third cluster, forward section through a crawlway tight enough that his shoulders scraped composite on both sides and his coveralls accumulated a gray stripe of decades-old dust. Notches present on the 7th gauge. Needle, 1.54. Software, 2.21. High by 0.67. Fourth cluster, deep in the station's port infrastructure spine behind a panel partially blocked by a cable run added during the second renovation. He shifted the cables, opened the panel, read the gauge. Needle, 1.22. Software, 2.33. High by 1.11 units. The pattern was geometric. Each gauge further from the primary intake showed a progressively wider gap between what the brass measured and what the software believed. The station's atmospheric monitoring system had been constructing an increasingly fictional version of its own pressure environment, each quarterly self-verification cycle accepting a slightly more wrong number as the new settled truth, the error compounding fraction by fraction, quarter by quarter, year by year. The digital model had been slowly, patiently, perfectly invisibly divorcing from the physical infrastructure it described. And because every alarm threshold, every safety margin, every routing decision was calibrated against the same drifting baseline, no warning had ever triggered. The system had been drowning in a sea of its own perfect self-agreement for what might have been decades, and every audit, every inspection, every quarterly verification cycle had confirmed that the drowning was proceeding normally. 33 minutes. Mora, I need you to authorize something your engineering protocols are specifically designed to prevent. What do you require? Override the automated baseline, all 7 atmospheric loops. Replace every software-stored pressure value with the corresponding reading from these analog gauges. Engineer Morse. Her voice was controlled, professional, exact. The harmonic buzz had not settled. Those instruments have been decommissioned for 26 years. They carry no current certification. They have not been maintained, inspected, or calibrated since disconnection. Our engineering standards do not permit the substitution of verified baseline data with readings from uncertified mechanical instrumentation. The liability implications alone. Your verified baseline is telling you that an empty pipe is pressurized. Your certified monitoring suite watched the primary loop shut itself down because physical reality contradicted the fiction the software has been building since before half your junior technicians were born. Mora, the analog gauges are physically incapable of lying. They are sealed brass tubes connected to real pipes containing real gas. The only force that moves their needles is actual physical pressure acting on actual metal. The notches scratched into their faces are the only calibration reference on this station that has never been touched by a self-verification algorithm. He heard the double inhale, gave her 5 full seconds. The countdown on his wrist dropped through 31. If the analog readings are wrong, she said, if the mechanical instruments have degraded over 26 years of disuse. Borden tube gauges do not degrade in the way you are imagining. The sensing element is a sealed metal tube in a sealed housing. The mechanical linkage is passive. Unless someone physically crushed or punctured the tube, It reads pressure today the same way it read pressure on the day it was manufactured. That is the reason someone carved reference marks into them, because they understood that the brass would still be reading true long after the software had drifted into a comfortable, perfectly verified, completely fictional version of reality. And if you are wrong, Engineer Morse, then we have replaced one set of uncertain numbers with a different set of uncertain numbers, and we are exactly where we are right now, burning through atmosphere with no working solution. If I am right, we save 914 people. The risk calculation is not complicated. 29 minutes, he waited. He could feel the decision balanced on the edge of Mora's silence. 41 years of Celari engineering culture, an entire civilization's foundational trust in digital verification, weighed against 7 scratches on brass, and a human contractor who was asking her to abandon every protocol her training had taught her to rely on. "Override credentials transmitted to your terminal," she said. The harmonic buzz was gone. Her voice was flat, clear, and absolutely committed. "Enter the analog readings manually for each loop. Our input systems do not support human standard pressure notation. You will need to convert each value to Celari standard before entry. Converting now, CDEC bypass, true pressure 0, enter 0. Tell the system that loop is dead and has been dead." He heard her relay the command, heard the station systems respond, a warning chime, sharp and insistent, followed by 3 more in rapid succession, then a cascading wave of alarms as the software processed the information that one of its monitored, verified, quarterly audited atmospheric loops was entirely empty. The chimes carried a quality that was almost personally affronted, the auditory equivalent of a system being told it was wrong about something it had verified to be correct 11 days ago. Then adaptation. With the CDEC bypass correctly logged as 0 pressure, the routing algorithm recalculated. It stopped trying to route air through an empty circuit. The primary intake, which had shut itself down because its honest readings did not match the baseline's fiction, received a corrected baseline that matched what it was actually measuring. It engaged. A vibration rolled through the deck plates, deep, subsonic, felt in the soles of Declan's boots and the base of his spine. The sound of atmosphere moving through real pipes at real pressures, rooted by a system that was, for the first time in years, working with real numbers. 24 minutes. Primary intake responding, Mora reported. The harmonic was back but altered, still stressed, threaded now with something he could not quite name. Not relief. Not yet. Something closer to the first tentative recognition that a catastrophe might be survivable. The intake mechanism is mechanically intact. The atmospheric processor is undamaged. It shut itself down because the pressure readings it was producing did not correspond to what the drifted baseline said those readings should be. It interpreted its own accuracy as a malfunction. It was your only honest instrument. It was reading real pressure in a system full of fictional numbers. When the real measurements contradicted the fiction, it followed safety protocol and shut itself down. Your system killed its most accurate sensor for the crime of telling the truth, because the truth did not match the consensus. He was already moving. Second gauge cluster, read the notch, called in the number. Mora entered it while her operations team watched their monitoring displays rewrite themselves. Comfortable green indicators flickering amber, then red, then settling back to green as the system lurched from its old fictional equilibrium toward an unfamiliar relationship with physical reality. Loop 2, notch reading, 2.14, software baseline, 2.89. He entered the corrected value. Warning chimes protested. A valve deep in the station's infrastructure opened with a resonant clunk, a valve that had been throttled nearly shut for years, strangling real airflow to compensate for a phantom pressure differential that existed only inside the software's model of a world it had stopped accurately perceiving. Mora's voice on the hardline had changed. The formal, careful diction of the first override request had given way to something faster, more clipped, the verbal signature of someone who had stopped debating whether to cross the line and was now focused entirely on how fast she could move. The routing compensation matrix for Loop 2 is unwinding. The system had been maintaining 14 secondary flow adjustments to account for the discrepancy between the fictional baseline and the actual pressure. 14 adjustments, engineer Morse. 14 separate algorithmic interventions, each one perfectly calibrated to compensate for an error that nobody knew existed. Each one burning energy. Each one consuming processing cycles and adding pressure drop to the system. The cumulative parasitic load from phantom compensations across all 7 loops, I am running the estimate now, may account for more than a third of the station's atmospheric processing energy overhead. We have been attributing that overhead to normal aging. It was not aging. It was the cost of maintaining a fiction. Declan absorbed that while moving to the third cluster, a third of the station's energy budget for atmospheric processing spent on compensating for numbers that weren't real. Years of maintenance reports explaining the creeping energy draw as expected degradation. Years of budget allocations for equipment that wasn't wearing out. It was being worked harder and harder to service a model that existed only in the software's memory. The Celari engineers had been solving the wrong problem with meticulous competence, and every solution had confirmed that the problem they were solving was the right one, because the diagnostic tools that identified the problem were the same ones generating it. Loop 3, Notch, 1.97, Software, 2.61. When the real number replaced the fictional one, 3 secondary compensator valves released simultaneously. The sound of air moving through the station's walls changed, deepened, steadied, lost a strained high-frequency overtone that had been so constant for so long that it had become invisible. One of the junior technicians on the open channel made a sound, a sharp, involuntary Celari inhalation. The flow harmonic, the technician said, it changed. It has been wrong for years. The system was pushing atmosphere through compensated routes to match its fictional model, and the pipes were producing a resonance they were not designed to produce. You have been hearing it every shift. You stopped hearing it because the system told you it was normal. 19 minutes. Loop 4 was the worst. The 7th notch read 0.41, barely above vacuum. The software read 2.15. When Declan entered the real number, the discrepancy was so extreme that the system interpreted it as catastrophic decompression. Every alarm on the station fired. Emergency bulkhead protocols activated on 3 adjacent decks. Automated evacuation warnings began cycling in 3 languages, while Mora spent 90 seconds countermanding the automated responses, talking her junior technicians through the bewildering process of accepting that the station was not blowing itself apart, but was instead absorbing the shock of accurate information for the first time in longer than most of them had served. The Loop 4 correction revealed something else. When the real pressure value replaced the fictional one, the routing algorithm attempted to redirect atmospheric flow through a secondary channel that the software had believed was available, and discovered that the secondary channel was also running at a fraction of its reported pressure. The cascade of fictions ran deeper than a single layer. The system had built compensations on top of compensations, routing atmospheric flow through increasingly convoluted paths to satisfy a model that bore less and less resemblance to the physical plumbing it was supposed to describe. Correcting one number exposed the wrongness of 6 others, each of which had been perfectly verified, each of which had been confirmed by quarterly audits, each of which had been wrong in a way that only an external reference could detect. How did no one notice? The young technician's voice, Toreth Declan would learn later, carried the high-frequency Celari distress harmonic, a sound like a wire being plucked and held. The verification audits, every quarter, the automated cross-checks. We ran every diagnostic. We followed every procedure. How did this pass every single inspection for 20 years? Because every inspection used the system's own numbers to verify the system's own numbers. Declan kept his voice level, a teacher's tone, not an accuser's. He was crouched inside the fifth gauge cluster's access panel, headlamp angled at the brass bezel, reading notches that had not been read by any living person in 4 decades. You compared the sensors to the baseline. You compared the baseline to the sensors. They agreed perfectly every time. They agreed because they were the same error, looking at itself in a mirror and confirming that its reflection was accurate. A perfect closed loop of mutual self-confirmation. The only thing that could have broken the loop was something from outside it entirely, something that does not update, does not self-verify, does not participate in the consensus. But the physical infrastructure, surely the flow rates, the energy consumption, the performance metrics would have shown. They did show it. Your atmospheric flow rates have been declining steadily for years. The system logged that decline as normal age-related efficiency loss within acceptable parameters. Your processing energy consumption has been climbing, logged as expected compensatory load within acceptable parameters. Your maintenance records show increasing frequency of adjustments to routing compensators, logged as standard calibration drift within acceptable parameters. Every single indicator of the problem was visible in the data. The data was invisible because every analysis of it used the same wrong baseline as its starting point. The evidence was hiding in plain sight, and the thing that was supposed to find it was the thing that was hiding it. Torith was quiet for a moment. The distress harmonic faded to something lower, more contemplative. Something like scratches on a brass gauge, he said. Exactly like scratches on a brass gauge. Loop 5. 15 minutes left on the countdown. The junior technicians were in the sublevel now, Torith and 2 others, Halleth and Rihanna, pulling access panels with tools borrowed from Declan's kit, because the sublevel maintenance lockers had not been restocked since the analog systems were decommissioned. They read gauge faces by headlamp, calling out numbers to Mora with the focused precision of people who had just discovered that the most fundamental assumption of their engineering training, that verified digital data, was inherently more reliable than unverified mechanical data, was not a law of physics, but a cultural choice that had nearly killed every person on the station. Rihanna, the most senior of the 3 juniors, found something at the 5th gauge cluster that stopped her mid-reading. Engineer Morse. The capillary tube on gauge 4 in this cluster, the one connected to the secondary distribution manifold, there is a repair splice here. The copper tubing has been cut and rejoined with a soldered sleeve. This is not original construction work. Someone repaired this gauge after installation. Declan moved to her position and examined the splice. Clean work. Precise. The solder joint was smooth and professionally done, with a slight oxidation pattern that suggested it had been made decades ago, long enough for the copper to darken uniformly around the repair. Daniel Core, he said. He did not just mark the gauges. He maintained them. He found a damaged capillary tube and repaired it so the gauge would keep reading true after he left. But his contract was for 11 months, Rihanna said. His performance review said he spent time on tasks not specified in the commissioning contract. This must have been one of those tasks, repairing an analog instrument that had already been scheduled for decommission, that no one had asked him to repair, that no procedure required to be functional. Yes. Why? Because the gauge was still connected to the pipe, because the pipe still carried atmosphere, because a broken gauge connected to a real pipe is a waste of a perfectly good truth-telling instrument, and fixing it cost him 30 minutes and a sleeve of solder. He left behind working references because he believed that someday someone would need them. He was right. He just did not know it would take 41 years for someone to come looking. Loop 6, 11 minutes remaining on the countdown. The corrected value released a cascade of compensators throughout the station's port infrastructure, and Verath call made a sound Declan had never heard from any orbital structure in 20 years of atmospheric work. A deep, resonant, almost musical hum as decades of accumulated mechanical stress unwound, and the atmospheric piping settled into alignment with its own physical reality for the first time in living memory. Pipes that had been vibrating at frequencies imposed by fictional flow patterns fell silent, then began to resonate at their natural frequencies. The tones they had been designed to produce, the sounds of an atmospheric system operating the way its engineers had intended it to operate. One of the junior technicians, Hawleth, the quietest of the three, said something in formal Celari that Declan's translation implant rendered as, "The station is singing in its original voice." It was the most accurate description of the sound that anyone would offer. The seventh loop brought him back to the gauge with the initials. He crouched in the deepest crawlway on the sublevel, the oldest part of the station's mechanical core, where original construction composite was exposed on every surface, and the renovation had never reached. The brass gauge gleamed under his headlamp, its housing darkened to the color of old honey. 7 notches, hand-carved, each one a fixed reference point in a station that had lost its relationship with fixed reference points a very long time ago. And beside the 7th notch, carved with the same sharp tool in the same steady hand, 2 characters, DK. Initials, a name compressed to its smallest possible form, a human being's mark on a piece of brass that had outlasted every digital system built on top of it. 7th loop, notch reads 2.31, software reads 3.47, enter 2.31. Entering now. The station screamed. Every alarm fired simultaneously, a wall of sound that hit the sublevel like something physical. Emergency lighting pulsed. Automated warnings cycled in 3 languages. For 15 seconds, the system believed it was witnessing the catastrophic failure of the deepest atmospheric loop in the station. Then it rebuilt, not patching, not compensating. Rebuilding the entire atmospheric model from scratch, using 7 real numbers scratched into brass by a man who had worked here 41 years ago, and had understood something about verification that the Celari's entire engineering philosophy had missed. That a system which checks itself against itself will always find itself correct, and that the only defense against a perfect consensus of error is a stubborn, inconvenient, unnetworked piece of physical reality that refuses to participate in the agreement. The algorithm discovered that the infrastructure it had been managing bore only a passing resemblance to the infrastructure it had believed it was managing. Pipes it thought were pressurized were empty. Valves it thought were open were closed. Compensators running at maximum were compensating for conditions that existed nowhere, except in the system's own increasingly elaborate fiction. New routes, through real pipes, at real pressures, valves opened, compensators released. The atmospheric processor received, for the first time in perhaps 2 decades, a set of operating instructions that matched the physical world it inhabited. The hum that followed was the deepest, steadiest, most resonant sound Declan had ever heard a station make. Not the strained vibration of a system fighting itself. The clean, powerful, subsonic throb of atmosphere flowing freely through infrastructure that was finally being used the way it was built to be used. 7 minutes on the countdown. The reserve indicator stopped falling, held steady. Then slowly began to rise. 914 people kept breathing. Declan sat in the crawlway, his back against composite older than most careers on this station, his hand resting on the 7th gauge. The brass was cool under his fingers. The notches sat beneath his thumb, 7 small ridges, each one precise, each one unchanged since the day it was carved. They were real in a way that nothing else on this station had been real for a long time. Not verified real, not consensus real. Physically, mechanically, stubbornly real, because brass does not update and scratches do not drift, and a tube of metal connected to a pipe of air will tell you the truth about the pressure in that pipe, whether anyone checks or not. Mora's voice came through the hardline after a silence so long he almost reached for the connection diagnostic. When she spoke, the harmonic buzz was entirely absent. In 14 months of working alongside Celari engineers, he had never heard one speak without it. Engineer Morse. I am here. The calibration engineer, Daniel Core. A pause that was not about data retrieval. I accessed his personnel file from the construction-era archive. He was contracted for 11 months during the station's first-year commissioning phase. Standard compensation rate. No special commendations. No contract extension. His quarterly performance review describes him as the translation into trade common is imprecise, methodical to the point of redundancy. His supervising engineer noted that he devoted billable hours to tasks not specified in the commissioning contract. Tasks like carving reference marks into gauges that were already calibrated by software. Yes, the review characterized it as an inefficient allocation of contracted time. It was logged as a minor performance concern. His supervisor recommended against contract renewal, citing this tendency toward undirected, unrequested work. Declan closed his eyes briefly, methodical to the point of redundancy. An 11-month contractor, standard rate, no commendations, not renewed, flagged for wasting billable time on work nobody asked for and nobody understood. Sitting in these same crawlways 41 years ago with a sharp tool, and a conviction that automated self-verification had a failure mode that nobody wanted to think about. Spending his professional reputation on the quiet act of scratching numbers into brass that no procedure required, that no specification mentioned, that his own supervisor considered a waste of contracted hours. And leaving behind, in 7 sets of 7 notches and a pair of initials, the most durable engineering document on the station. One that had outlasted every digital system, every software upgrade, every automation cycle, every quarterly audit, and every comfortable fiction the building had wrapped around itself. He left no documentation of the notches, Mora continued, no instructions for locating them, no explanation of the calibration points or the unit system, no memo, no annotation in any archive. He simply made the marks, completed his contract, and moved on. The marks are the documentation, Mora. A pressure gauge with 7 reference notches in human standard units, mounted on a pipe. That is a complete instruction set. The brass is the manual. Any engineer who finds it and understands what a Borden tube measures has everything they need. The fact that it requires a human to read human units is not a flaw. It is a feature. It means the verification requires a person to be present. A person who is looking at the gauge, reading the number, and deciding whether it matches what the system says. A person who is outside the loop. The recovery took 11 days. Declan supervised the recalibration of every atmospheric system on Verath call gauge cluster by gauge cluster, loop by loop, notch by notch. They found drift in every circuit on the station. The smallest gap was 0.14 units, in the loop nearest the primary intake, a discrepancy small enough that it might not have mattered operationally for another 5 years. The largest, beyond the C-deck bypass ghost, was the 1.74 unit chasm in loop 4, a loop that had been functionally inoperative for an estimated 12 to 15 years, while the software maintained an immaculate, thoroughly verified, completely fictional record of its full nominal performance. On the second day, the maintenance crews discovered that 2 additional bypass couplings, not just the C-deck unit, existed only as software phantoms. The physical components had failed years ago, corroded to nothing inside their housings, but the monitoring system had continued to report them as functional because the baseline drift had masked the pressure loss. Each failed coupling had been compensated for by the routing algorithm, which had quietly rerouted flow through increasingly tortuous paths. each reroute adding energy overhead, each overhead increase logged as normal operational aging. The station had been slowly strangling itself, and every metric it used to measure its own health had confirmed that the strangling was proceeding within acceptable parameters. On the fourth day, one of the senior Solari engineers, a woman named Prelis who had served on Verathkal for 19 years, sat down in the sublevel corridor, put her back against the wall, and stared at the row of brass gauges for 20 minutes without speaking. When Declan asked if she was all right, she said, very quietly and without the harmonic buzz that should have accompanied a statement carrying that much emotional freight, "I signed off on the last 8 quarterly verification audits. Every one. I confirmed that this system was operating within specification. I confirmed a fiction. I was the auditor, and I could not see what I was auditing, because the thing I was using to look was the thing that was lying. The system was designed to make the audit invisible," Declan said. "That's not a failure of competence. It's a failure of architecture. The audit was inside the loop. It needed to be outside it. I should have checked." "Checked how? With what instrument? Every tool you had access to was calibrated against the same drifting baseline. You would have needed to go outside the system to see the drift, and there was nothing outside the system. That's the gap Daniel Core filled, Prelis. Not because he was smarter than you, because he had a different habit. He distrusted self-referential systems the way you distrust uncalibrated instruments. Instinctively, professionally, as a matter of engineering discipline." She looked at the 7th gauge, at the DK scratched into the bezel. He was not smart enough to document it properly, he just scratched metal. He was smart enough to use a medium that cannot lie. That's a different kind of intelligence than documentation. It's the intelligence of choosing the right material for the job. Torith worked alongside Declan through most of the remaining recovery. He was quiet for the first 2 days. The acute distress harmonic had given way to a lower, more contemplative frequency, the sound of a mind carefully disassembling its own foundations and examining each piece before deciding whether to retain it. On the 3rd day, he brought a handwritten notebook into the sublevel and spent an entire 8-hour shift sitting cross-legged in front of a gauge cluster, recording the analog pressure reading every 10 minutes alongside the software reading. 2 columns of numbers on a paper page. 2 versions of the same pipe, the same gas, the same physical pressure, disagreeing by 0.71 units, every reading without variation. "The gauge does not move," Torith said. "The software does not move. They disagree by exactly the same amount every time. The gap is perfectly stable. The error is perfectly stable. The fiction is perfectly stable. That is somehow worse than if the numbers were jumping around. The system has settled into a steady, permanent, perfectly confident wrong answer. The gauge is right. The software was right once, maybe for the first 5 years, maybe longer. Then the transducer drifted, not much, a fraction of a unit per cycle, and the self-verification protocol accepted the drift because it was within tolerance and adjusted the baseline to match, and the next reading was verified against the new, slightly wrong baseline, quarter after quarter, year after year, each cycle correct relative to the previous one, each cycle a fraction further from reality. And because the reference was moving with the error was invisible. The system was lost, and it did not know it was lost, because every landmark it navigated by was lost in exactly the same way. How do you build a verification system that does not do this? You cannot. Any closed-loop system that verifies itself against its own output will drift eventually. That is not an engineering failure. It is a mathematical property of self-referential feedback loops. The question is never how to prevent drift. It is how to detect it. And the answer is always the same. You need something outside the system, something that does not update, does not self-adjust, does not participate in the consensus. Something that just sits there, connected to the real world by physics rather than by software, measuring what is real. Torith looked at the notches on the brass, at the tiny DK carved beside the seventh mark. He understood this. Your Daniel Core, 41 years ago, as an 11-month contractor with no special commendations, he understood a failure mode that our entire engineering culture had assumed could not exist. He did not need to understand it theoretically. He just needed to distrust the system enough to leave a mark that was outside it. That is a human habit, Torith, not genius. Habit. The habit of checking the thing you have been told is fine, because the act of checking costs almost nothing, and the cost of not checking, once in a great while, is everything. On the 9th day of the recovery, Maura called Declan to the operations center. She stood at her primary interface, a wide holographic display showing the station's atmospheric model in real time, all 7 loops running at their corrected pressures, flow patterns smooth and stable for the first time since before the crisis. Through the office windows, the daylight panels cast their permanent noon across the upper deck. The recalibration audit is complete, she said, before addressing the regulation. I want you to see the summary before I discuss what the regional authority has done with it. She pulled up a comparative display, 2 models of the station's atmospheric system side by side. The left model was labeled pre-correction and showed the system as the software had believed it existed. 7 loops, all pressurized, all flowing, all verified, all green. The right model was labeled post-correction and showed the system as the analog gauges had revealed it to actually exist. 3 loops operating at less than half their reported pressure, 1 loop completely dead, 2 loops functioning but routing through compensated paths that added 40% energy overhead, and 1 loop, the primary, the one that had triggered the crisis by shutting itself down, that had been the only circuit on the station operating anywhere close to its design specification. The energy cost, Maura said. The atmospheric processing system has been consuming 37% more power than its design rating for the last 8 to 12 years. We attributed the excess to normal aging and component degradation. The excess was actually compensation energy. The system working harder and harder to push atmosphere through routes that did not match its physical infrastructure, burning power to maintain a fiction. The secondary discovery, Maura continued, is more troubling. During the recalibration, we identified 6 additional component phantoms across the atmospheric network, physical components that have failed, degraded, or been consumed by corrosion, but whose failure was masked by the baseline drift. The monitoring system continued to report them as functional because the drifted baseline absorbed their absence into its fictional model. The system did not merely lose accuracy over time. It lost components. Real, physical pieces of hardware ceased to exist, and the system's response was to quietly adjust its model to account for their absence without ever acknowledging that they were gone. The system papered over reality. In the most literal sense, it constructed a narrative in which every reading was consistent, every pressure was nominal, every flow rate was within parameters, and the narrative was internally flawless. The only flaw was that it did not describe the station. And now, energy consumption dropped to within 4% of design specification within 72 hours of the baseline correction. The atmospheric processor is operating more efficiently today than it has at any point in the last decade. We have not changed a single mechanical component. We changed only the number the system uses to understand itself. She let that statement hang in the bright office for a moment, then continued. The Celari Regional Engineering Authority has drafted a new regulation, she said, turning the display to show a formal document. Mandatory analog reference instrumentation in all atmospheric processing facilities across the region. Physical calibration marks, verified by direct mechanical measurement, immune to software update or baseline drift. He read the regulation. Formal Celari administrative language, careful, precise, the kind of document that would be distributed to facility managers across the region and incorporated into the engineering standards within a year. But the technical appendix was different. It specified the gauge type, Borden tube, brass housing, glass face, sealed mechanical linkage. It specified the marking method, hand-carved notches at defined pressure points along the operating curve. It specified the unit system. Human standard pressure units. He read that line twice slowly, letting the weight of it settle. Then he read the appendix's final paragraph, said in smaller type, almost a footnote. Each reference gauge shall bear the installing technician's personal mark, hand-carved into the brass bezel adjacent to the 7th calibration notch. No rationale cited. No reference to Varathkal, to Daniel Core, to the 41 years of cascading drift that had brought a station within 7 minutes of suffocation. Just a specification, folded quietly into the regional engineering standard, requiring that every analog reference gauge in every atmospheric facility in Celari space carry 2 letters scratched into brass by a human hand. The initials requirement, Declan said, was added by the authority's chief standards engineer, a Celari named Doreth Venn. Mora paused, the double inhale. When asked to explain the requirement during the formal review, she stated that the purpose of the personal mark is to ensure that every gauge carries evidence that a person verified it, not a system, not an algorithm, not a protocol, a person with a hand and a tool who stood in front of the gauge and confirmed that the number was true. She said the mark transforms the instrument from a gauge into a testimony, that a number scratched by a hand carries a weight that a number generated by software does not, because the hand was there. The hand touched the pipe. The hand felt the pressure. The hand decided the number was true and committed it to brass, and that commitment is the thing the system cannot replicate. Declan looked at the regulation for a long time. Through the windows, the daylight panels held their unchanging noon, and beyond the station's hull, Tesseri's moon hung in a sky that 914 people were still breathing in, because a man with no special commendations had spent his own billable hours scratching numbers into brass that nobody had asked him to mark. The gauge from the 7th cluster, he said, the one with Core's initials, where is it? Removed during the overhaul, replaced with a new unit per the updated standard. The original is in storage on sublevel 2, awaiting disposition. Can I have it? The silence lasted 5 heartbeats. Then, with no harmonic buzz at all, in a voice so quiet it barely carried, I will have it sent to your quarters. The gauge arrived that evening. Small, heavy, brass darkened to the color of late afternoon light, glass face hazed with 41 years of still air, needle resting at 2.31, the last true reading it had taken before disconnection, still pointing at the number its maker had marked as the 7th notch, still holding the truth it had been built to hold. Beside the 7th notch, in scratches almost too fine to see, DK. Declan turned it over in his hands. The brass was warm from the daylight panels. The notches sat under his thumb, 7 ridges, precise, permanent, unchanged since the day a man named Daniel Core had pressed a sharp tool into metal and decided that some truths were too important to trust to anything that might change its mind. The weight of the gauge was solid and real in a way that went past its physical mass. It was the weight of a professional act that had been invisible for 4 decades and had turned out to be the most important thing anyone had ever done on the station. He set the gauge on his desk beside his own tools, picked up his kit bag, headed for the sublevel, where the new gauges waited, clean brass, clear glass, fresh Borden tubes connected to real pipes carrying real atmosphere. 7 notches to carve on each one, his own initials to scratch beside the 7th mark. And the knowledge, settled and certain in his hands, that the brass would hold the truth long after the last software update had run its course, and the last verification cycle had confirmed the last comfortable fiction. Because scratches do not drift, and metal does not forget, And the most durable thing a human engineer can leave behind is a number he checked with his own hands, carved into something that will not change its mind.